Welcome back to the GCSE Maths Pro YouTube channel. Today we're going to be looking at factorising harder quadratics, but specifically by using the splitting the middle term method. If you haven't seen factorising harder quadratics with the trial and error method already, go check out that video. As you can see, this is the third part of factorising quadratics. It's just basically another option for a method when you're dealing with harder quadratics. So you've got the option of just using the trial and error method as normal, or if you find that particularly difficult, splitting middle term method helps to eliminate as much of trial and error as possible and make it a little bit easier to work through. So what do we mean by harder quadratics? Well, basically it's the quadratics where we've got a number in front of the x squared, and I would say more specifically a number that's not a prime number. So prime numbers are those numbers where the only factors are 1 and itself. For example, 2, 3, 5, 7, 11, so on. 6 is obviously, you can do 1 times 6, you can also do 2 times 3. Okay, so it's not a prime number. The issue with that makes it harder is that then we've got so many possible combinations that we have to try and figure out, on top of already trying to figure out the combinations of 12, 17, and so on. So that's what we mean by harder quadratics. Therefore, sometimes trial and error method can be really, really difficult if you've got so many possible combinations to figure out. So the splitting the middle term method is here to try and reduce the trial and error part. So what we're going to do is, quadratics are normally written in this format: ax squared plus bx plus c. A, b and c just represent the coefficients. So for example 6, 17, 12, that's what a, b and c are. What we're going to do is we're going to come over to this corner, we're going to do a times c. So 6 times 12. Now obviously if that c is a negative, include the negative, right? But in this case they're both positive. So 6 times 12 gives me 72. So what I'm looking for, and this is where it's very similar to trial and error, is I'm looking for two numbers that multiply to make 72, but they also add up to make this middle number, the b, minus 17. So before we figure out the factors of 72, as always, we need to know what symbols do we need. So we're multiplying to make a positive, but when we add them together, it's negative. So we're going to need two negatives. Then I'm thinking, right, factors of 72. Which ones would add together to make minus 17? Now when they add together to make minus 17, as in the total is minus 17, in themselves they're probably quite small, so you can probably already see which ones those are going to be. Like obviously it's not going to be 1 and 72, is it? Because if you add those, nowhere near 17. So it kind of helps me narrow it down. I'm just immediately assuming it's going to be 8 times 9. Because that makes 72, but also 8 plus 9 is 17, isn't it? So I've got minus 8 times minus 9 is positive 72. Minus 8 plus minus 9 is minus 17. Okay, now that bit is basically the same. Obviously the difference is we've done a times c first. So we're not figuring out factors of 12, we're figuring out factors of 72. Now I'm going to come back to the middle. This is what we are referring to when we say splitting the middle term. The middle term is the b, isn't it? Literally this term in the middle. That's what we're going to split. So what you're going to do once you've done this, I'm going to call that, right, that's step 1. Step 2 is you're going to rewrite your quadratic, but split the middle term into these two values. So what I mean by that is I'm going to write the 6x squared still, but instead of writing minus 17x, I'm going to write, now it doesn't matter which order you put them in either, you just put them whichever order you like, but use obviously the correct symbols, minus 8x minus 9x. Now overall that still adds up to minus 17x, doesn't it? And then I'm going to copy the plus 12. Okay, so this is exactly the same quadratic as the top one. I've just split the middle term. Okay, I've literally split it. What we're going to do now is we're going to factorise, but it's a lot easier because we're going to factorise into single brackets. So imagine there's a little line here. If you just look at the first two terms, how can we factorise that into single brackets? What is the highest common factor between 6x squared and 8x? Well, in terms of numbers, that's going to be 2. And in terms of the letters, we've got an x, haven't we? Then in the brackets, to get from 2x back to 6x squared, I have to times it by 3x. And then to get from 2x to minus 8x, I need to times by minus 4. Okay, and then we're going to factorise the second bit. So the highest common factor between minus 9x and plus 12 is 3. Now this is where you've got to try and figure out the symbols. You know, am I going to pull out the negative out here? I'm going to put it inside the bracket. I'm going to deal with that in a minute. I'm just going to write down the numbers and the letters. We'll deal with the symbols in a minute. So to get from 3 to 9x, I need 3x. And to get from 3 to 12, I need 4. Now, this is where you'll know whether you're right or wrong, because these two brackets have to be identical. Okay? So first of all, if they're not identical, you know you've done something wrong. But second of all, the fact that I know they need to be identical tells me I have to have this as a negative. Therefore, I know that I need to put a negative on the outside. Okay, so when I times this, I get minus 3 times 3x, gives me the minus 9x. But then I do minus 3 times minus 4, gives me that positive 12. Okay, so they have to be identical brackets. Now, your final step is your answer. We're going to create, obviously, the actual two final brackets. One of those brackets is obviously going to be one of these two. So they're identical, so you only need it once. So 3x minus 4. Okay, so these need to be identical, and that's going to be one of your brackets. And then the other bracket's going to be whatever else is on the outside, so you can see these two pieces are separate. So we've got 2x minus 3. Okay? This is your final answer here. So you can see, if you've already watched the video that we did on using the trial and error method, we would have had to figure out if it was going to be 6x and x in the brackets or 3x and 2x. You can see in this method, it's figured it out for us. We didn't even have to worry about this first term. Okay, we just had to do a bit of trial and error on the side, but it didn't really involve the first term that much, did it? And obviously factorising into single brackets is pretty straightforward. And I actually quite like this method as well, because you can guarantee that you've got the answer right, because if you've ended up with the two brackets being identical, you're pretty sure that you've got it right. Okay, so you've got some kind of like positive feedback there. So we are still doing a bit of trial and error in this corner, but it's not as much as trying to figure out the 6x squared and the 12 and this and that. But as you can see, we had to have two negatives anyway, so we've got that. 3x and 2x would multiply to make 6x squared, and 4 and 3 makes 12, so that's worked out anyway. Even though we used 72, it still worked itself out. So that is the whole of the splitting middle term method. If you haven't seen it before, it might take a while to kind of really remember it. You might decide, you know what, it's just easier if I remember one method, trial and error for all of my quadratics. Absolutely fine. However, if you're really struggling with the trial and error method for these harder quadratics, you might be happy to have two methods. Obviously, this method is kind of pointless if it doesn't have a number in front of the x squared. Because if you then do a times c, you're doing 1 times the c. So it's not making any difference, is it? So this is only really a method for when you've got a number in front of the x squared. You just decide, do I want to memorize two methods? Is that going to make my life easier? Or is it just easier to have one method and not complicate myself? Completely up to you. But let's go through another example, okay? So as we said, the a is the number in front of the x squared and the c is the number at the end, but remember it's including the symbol. Okay, so this one is negative. We're going to come over to the side and we're going to do a times c. So step 1, a times c. Okay, so 12 times minus 4 is minus 48. So we need two numbers that multiply to make minus 48 and add to make minus 22. So just copy that middle number as normal anyway. Okay, so multiply to make minus 48 and add to make minus 22. Before we do that, we always like to figure out the symbols, don't we? So if we're multiplying to make a negative, we're going to have a positive and a negative, aren't we? 1 plus, 1 minus. I'm just going to put a minus here because we don't really need to write the plus. So factors of 48. And if you remember in our previous video on trial and error, when you've got a plus and a minus, this 22 is the difference between them. So it's quite far apart, really, the factors. So factors of 48, obviously 1 and 48 is still too far apart. But we've got 2 and 24. Now the difference between 2 and 24 is 22. So I'm going to go with it being these ones. Now we need to figure out which is positive, which is negative. If I need it to be negative 22 overall, I'm going to need the bigger number to be the negative, aren't I? So we've got positive 2 plus minus 24. That's going to give me minus 22. Okay, so those are our two numbers. Step 2, we come back over here. We're going to rewrite the quadratic out, and we're going to split the middle term into these two numbers we have. Obviously put x's with them because the middle term is the x term, isn't it? So copy the 12x squared. Again, it doesn't matter which order you put them in, so I'm going to put plus 2x first, then minus 24x, copy the same symbols, and then just copy that last number, minus 4. And then we're going to be factorising 2 halves, so draw a little line there. So I'm going to factorise the first bit, which the highest common factor would be 2x. Then inside I need 6x plus 1. Then on the other side, again, kind of ignore this symbol first. We're going to deal with the highest common factor is 4. So then I need 6x and 1. Now, as I said before, you know that the brackets have to be identical, so we know this is going to have to be a plus, which means I'm going to have to pull out the negative again. Okay, because when I expand that, I've got minus 4 times 6x, which means minus 24x, and minus 4 times 1 is minus 4, isn't it? Okay, so make sure you've got that symbol correct as well. And our final step is then to just gather the two brackets. So one of our brackets is obviously just copying the brackets that are there, so 6x plus 1, that's just your first bracket. And your second bracket is then whatever's on the outside, so that is the 2x and the minus 4. Put that in the second bracket, 2x minus 4. And there you go, really fast, much faster than trying to do the trial and error method if you've got this memorized, obviously. Give this one a go, refer back to the previous questions if you want to check out the 3 steps again. But we're going to start off with step 1, which is where we do A times C. Okay, so A is 8 and C is 9 in this case. They're both positives, that's a little bit easier. So 8 times 9 is 72. So we need 2 numbers that multiply to make 72, but when you add them, they make minus 27. That's the thing to take into consideration. Okay, so not just 27, but minus 27. So what symbols do we need first? Well, we're multiplying to make positive. So we either need both plus or both minus. But when we add them, it's negative. So we're going to need both minus. So I'm just going to write that in, minus and a minus. Now we can focus on factors. Factors of 72 that would add together to make minus 27. In this case, it's not the difference, is it? It's just that they do add up to make 27. So factors of 72, obviously we're not really going to do 1 and 72, 2 and 36, so on. That's already too big, isn't it? We need it to be 2 factors that in themselves are smaller than 27. So I'm going to skip those. What have we got then? 3 and 24. Oh, yep, 3 and 24 would work, wouldn't it? 3 times 24 would make 72. But also, if they're both negatives, it would add up to minus 27. Okay, so that's pretty straightforward. We don't really need to worry about which order because they're both negatives. Step 2 is to then write out your quadratic again, but split the middle term with those 2 numbers you've just got. So I'm going to split it. Again, it doesn't really matter which order you put it in, but in this case, I'm just going to actually put it in the order of, I'm going to put the 24 first, just because I know that factorising that's going to be easier, and minus 3x with the 9. But like I said, it doesn't matter, you'll still get the same answer if you put it in either order. We're now going to factorise both into single brackets. So the first one, highest common factor is 8x. Then we've got x minus 3. Okay, so we know the second bracket's also going to have to be x minus 3, so we can bear that in mind. Highest common factor of the second bit is 3, and we'll deal with our symbol at the end once we've figured out. So 3 times x to make 3x, 3 times 3 to make 9. Now, you can see the previous bracket has a negative here, so we need that to be negative, which means we're going to have to pull out a negative here, so that we get minus 3 times x, which is minus 3x. Minus 3 times minus 3 is positive 9. Okay, so those brackets have to be identical even in the symbol. That's really important. And then your final step is to just write the 2 brackets together. So we know that one of the brackets is going to be the x minus 3, and the second bracket are the 2 parts on the outside, so 8x minus 3 as well. And you can see we already said we need 2 negatives, so it has come out as 2 negatives. You can see that the 3 times 3 makes 9. And we've not even had to worry about how to split the 8. Okay, we didn't need to worry about it being 8 and 1 or 4 and 2. We didn't know that, but it figured it out for us, which is why I think it's a lot faster. Okay, this is our last question, so try this one out yourself, pause the video, and then come back to see if you are happy with the method. So back to the same again, A and C. A times C is our step 1. So 20 times minus 15. Okay, so we're going to get minus 300. Now this is the only thing that could be slightly difficult, but hopefully you'd have a calculator test if this came up, is because obviously, okay, 300 is an alright number, but it is quite a big number, right? So finding factors, sometimes if you end up multiplying the A and the C together, you might get quite a big number, and that can sometimes be a little bit harder. So it's really up to you if you think this is easier or if you don't. Okay, so we need 2 numbers that multiply to make minus 300, but they add up to make 13. So what symbols do we need? Well, if we're multiplying to make a negative, we need a positive and a negative, don't we? So I'm just going to write the negative here, because I don't really need to write the positive. But if you remember, when we have a positive and a negative, this middle number is the difference between the two factors of 300, isn't it? So 13, in the context of 300, I guess those factors are fairly close together. You know, it's not 1 and 300. It's not 2 and 150, right? They're fairly close together. So that helps us narrow it down a little bit. So factors of 300, obviously, like I said, I'm not going to just write down 1 and 300 and so on. I'm looking for things that are a bit close together. The other thing to consider is if there's a difference of an odd number, we can assume, obviously, that 1's an even number, 1's an odd number. So that gives you a bit of a hint as well. Obviously, we use 20 and 15 anyway to make 300, but the difference between those two is 5. It's not big enough difference. So we're looking for numbers that are like one number that's smaller than 15 and one that's bigger than 20, but not too far beyond that. So if we think about it, obviously we have 10 and 30. The difference would be 20. That's then too far. So we've got, what did I say, 10 and 30. Well, the difference is 20, too big. And then we already used 15 and 20, didn't we? Where the difference was 5. So you can see by process of elimination, I can see I need something where the factors are between these two numbers. Now, thinking of 300, I'm thinking kind of towards 12. And what do I need to times 12 by? Well, it's actually 25, isn't it? Now, the difference between those is 13. You can see one's even, one's odd. Those are the ones that are going to work. Okay, so I can kind of, even though 300 is a big number, it's got a lot of factors, just by really just thinking about it logically, I can kind of limit myself. I can limit the time by not having to test out every single number. Okay, I can kind of give myself a guide as to what I'm aiming for. Now we need to know which one is positive, which one's negative. So you can see when we add them together, we get positive 13. So the bigger number has to be the positive. So we need 25 and minus 12. Okay, so that would multiply to make minus 300, and it would add to make 13. So step 2, we're then just going to rewrite the quadratic, but split that middle term, so the middle 13, into these two numbers. Again, doesn't matter which way around you write them. So I'm just going to put plus 25x minus 12x, and obviously then copy the rest, minus 15. Okay, we're not using the 300 anymore, right? Then we're going to factorize both halves into single brackets. So the highest common factor between 20x squared and 25x is going to be 5x. So inside I then need to put 4x and then plus 5. So now I know my second bracket's also going to have to be 4x plus 5. Okay, highest common factor for the second two, 12x and 15, is 3. And then I know that can be 4x and 5, but as I said, we need to have identical brackets. So it's going to have to be a plus. So again, we're kind of in this situation again where we need to pull out the negative. You don't always have to, it just depends. These kind of examples we've just been having seem to be all similar, but you don't always have to pull out the negative. But in these cases, we have had to. Okay, and our final step is to just write out our final answer in two brackets. So, as I said, the first bracket's going to be 4x plus 5. I mean, it doesn't technically matter which way around you write them. It's just whichever comes first, but I just had to put those first. It's a bit more obvious. And the second bracket is then whatever is on the outside of the bracket. So we've got 5x minus 3. And you can see we said before we need a plus and a minus, which we've got. To make 15, they've gone with 5 and 3. That's what we've ended up with. And to make 20, it's been split into 4x and 5x. We didn't need to worry about how the 20x squared was going to be split up. It just figured it out for us, didn't it? So we didn't know, is it 20x or x? Is it 10x and 2x? Is it 4x and 5x? We didn't need to worry. It literally just figures it out for you. Okay, so those are some good examples on splitting the middle term method. You can now decide which you prefer in terms of the trial and error method or the splitting the middle term method for harder quadratics specifically. The last part of factorising quadratics is the next video on factorising the difference of two squares. Okay, so that's super easy, but it's definitely something you should check out because it always comes up in the exams and a lot of students get caught out on it because they don't recognise it. And it's just so easy, okay? So it's not harder than what we've just done, don't worry. We've done the hardest bit already. So thanks for watching this video. Leave any comments down below. Make sure to subscribe and check out the difference of two squares video next.